may ask yourselves, blunt or non-blunt terms, who cares? Right? There's a lot of ways of phrasing that, but all right, who cares? So why do we care about C? Why is this such an important random variable? So it's as follows. Let's just use this one as an example. Let's say X represents, the random variable represents the weight of bulls. Okay? Let's say X is normally distributed. The mean weight of a bull is 500 pounds. The standard deviation is 100. Okay? So the average bull weighs 500 pounds and the standard deviation is 50 pounds. And let's say I wanted to know the probability that a bull weighs less than 550 pounds. Okay? Trying to price bulls, I don't know, for some reason I want to know what percent of bulls weigh less than 550 pounds. To me that's important in terms of my business. I want to know what percent. I also want to know how much to charge. Is my bull so heavy that I should charge a lot of money? Or is it, I just want to know, I want to know how fat my bull is. Okay. So when you think about 550, you shouldn't think of the number, you should think of this in terms of the distance from the mean. And you should think of it as the distance from the mean in standardized units. You should think of, when you think of 550, you should think of the standardized value of 550. So how far is 550 away from you? What is the standardized value of 550? 550 is what distance from the mean? How many units away is it? How many pounds away is it from the mean? 50 pounds. But how many standard deviations away is it? Positive 1. It's 1 standard deviation away from the mean. So this, the equation again is x minus mu divided by sigma. Okay? So here it would be little x is 550, so it would be 550 minus 500 divided by 50, or plus 1. So the probability that a bull weighs less than 550 pounds is the same thing as saying the probability that z is less than 1, which is 0.8413. Let's do another example. Let's say I wanted to find in this example, I asked you to find the 84.13 percentile of X. I wanted to know what percent of bulls, I wanted to find me the 84.13 percentile of bull weights, okay, of bulls. I want to know 84.13% of bulls weigh less than some number, and about 15.87% of bulls weigh more than one number. So I would be like, okay, no idea, where do I start with this? So you start with finding the probability, you find the step 1. You find the 84.13 percentile of Z. And that's equal to Z equal to 1. Okay, now how does that help me? Okay, then we Z is equal to 1. Now I want to find an X value. I want to find an X value with a Z-score of, with a standardized value of plus 1. Okay, well how do I do that? Let me do that. That's equal to the standardized value, Z equal to plus 1 is equal to little x minus mu divided by sigma. In other words, it's x minus 500 divided by 50, and I solve for x. I cross multiply, I get 50 is equal to x minus 550, 500, and I get x equal to 550. Okay, let's do this again a couple of times, because obviously you did not get it the first time. Or if you did, congratulations, you're smart enough. All right, so let's do another couple of examples like that. So I wanted to know what percent of bulls weigh less than 570 pounds. But I know that the distribution, generally bulls weigh something like this, that's their weight. The mean is 500. Bulls are normally distributed. The average bull weighs 500 pounds, the standard deviation is 50 pounds. But I have no idea. So how do I do this? I don't have a cumulative distribution function for bull weights. I only have a cumulative distribution function for what random variable? Not for x, but for z. This is a cumulative distribution function, not x. This is a cumulative distribution function of z. So how do I answer this question? Am I screwed? The answer is no. I'm not screwed. How do I do this? So I think about the number 570. What percent of bulls weigh less than 570 pounds? And I think about that number. I say, okay, how far is 570 away from the mean? Actually, let me choose a different number. Let me choose 620. This table's screwed up. Bad table. 620. That's also bad. This table is really screwed. Let's use 480. Let's use 380. What percent of bulls are very, very skinny? 380 pounds. They're lightweights. What percent of bulls are lightweights? Weigh less than 380 pounds. I can't sell a bull that weighs less than 380 pounds. No one's going to buy it. Okay? So what percent of my bulls are going to weigh less than 380? So I have to think, how far is 380 away from the mean? How many pounds away is it away? How many pounds away is 380 away from the mean? It is 120 pounds away. So the question then is, how many standard deviations away is it? So I count on my fingers. Well, it's not one. It's 150 pounds. 50 pounds, it's 2. So it's, what's the z-score of 380? How far is 380 away from the mean? So it's 380 minus what? 500. So it's 100, that's the numerator. So it's a negative 120 pounds away. And then what do I need to do? To count the standard deviations, I divide by 50. All right, I do that, and I get negative 1.4. Okay, so the probability that a bull weighs less than 380 is the same thing as saying the standardized value is less than negative 1.4. Yes. Yeah, negative 2.4, you think? This whole counting thing is tricky. 2 points. Very good. Alright, so what's the probability C is less than negative 2.4? It is. So you consult your Z table and you look at the cumulative. This is a cumulative distribution function. So you tell me that. You look at row K and you look at the first column and you see it's 0.0082. You answered a question that sort of, you answered a question that you didn't necessarily think of the answer. And again, this goes back to the quiz, the first quiz, calculating. One of the questions in the first quiz was a question about z-score. The reason it was because it's pretty essential for doing right. Say I wanted to find the 27.09 percentile of bulls weights. Well, I don't have a cumulative distribution function for bull weights. Again, what do I have? I only have a cumulative distribution function of z. So what do I do? Instead of finding the 27.09 percentile of x, I find the 27.09 percentile of z. Okay, let's see if that helps. That's helpful. Okay, so the 27.09 percentile of z. Percentile of z is, someone said it's in row AC, it's negative what? Negative 0.6. Negative 0.61. Alright, so how does that help me? So z equal to negative 0.61 has z equal to negative 0.61 is the 27.09 percentile of z. Oh, okay. So what? Now what? I'm looking for an x value that has a z-score of, what is the standardized value of negative 0.61. So I'm going to find an x with the z value, with the z-score of negative 0.61. Okay, so what does that mean? What is the equation for the z-score? The equation for the z-score, again, is x minus mu, which in this case is 500, divided by 50. And that's the z-score, and that's equal to what number? 61. So if I solve this, blah, 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 I get x equal to 500 minus 50 times 0.61, or a bowl that weighs, so what does that mean? Someone explain to me what 469.5 pounds means. That means what? Someone explain to me. Yes? Right.
27.9.
Good. But let's flush it out a little more. Someone or continue the sentence. Yes. Exactly. Perfectly expressed. So let me just repeat what you said. Say literally the same thing. That 27.09% of bowls weigh less than 469.5 pounds. That's why it's 27.09%. So that's a pretty impressive technology. And it turns out, we're going to just explain why later on. So I know you guys are very excited about that. We'll explain later on why a lot of distributions are normal. But the fact is, a lot of distributions turn out to have a normal distribution. And so we're able to answer these questions as well. So let's say you have hedge fund. Let's say we were talking about something near and dear to something I find more interesting. I probably don't. But let's say we're talking about hedge fund returns, okay? So let's say we're talking about X as hedge fund returns. Okay, and let's say an average hedge fund returns, let's say, I don't know, 10% a year, and the standard deviation is 2%. Okay? So, okay, that's interesting. So it's a normal distribution, and the average hedge fund returns 10% with a standard deviation of 2%. So this is mu, and this is the standard deviation sigma. That's usually often how it's written. Okay? And I want to know what percent of hedge funds return less than, let's say, 12%. Well, again, this is the cumulative distribution function of 12%, but I don't have a cumulative distribution function for hedge funds or for this thing. I only have a cumulative distribution function for C. So I have to think, how far is 12% away from the mean? Again, the distance from the mean is 0.02, and in standard deviation it is plus 1 standard deviation from the mean. So the z-score of 0.12 is 0.12 minus 0.1 divided by 0.02, or plus 1. So this is equal to the probability that C is less than plus 1, or equivalently 0.8587. 8413. And so now I know that 84.13. So now someone's trying to sell me their hedge fund, and they told me, I returned 12% last year. I say, yeah, you did pretty well because 84.13% of hedge funds returned that amount or less, and you were in the upper, basically 16th percentile. your hedge fund did relatively well. So your performance-wise, you did a decent job. So that to me is an interesting number. Let's say I want to find the 88.88th percentile of hedge funds. I want to find the 88.88th percentile of hedge funds. How do I do this? Again, I don't have a percentile, I don't have a cumulative distribution function table for X. I only have it for Z. So instead of finding the 88.88th percentile of X, I find the 88.88th percentile of Z. Okay, so step one, I'm going to find the turns out that that number is, someone tell me, Z equal to positive 1.22. Okay, that doesn't, great, so now I had what the 88th percentile of Z, but now I want to find the 88th percentile, not of Z, but of X. Okay, so what am I doing? Well, now look for a Z, I'm looking for an X, and now find an X with a Z-score of what? Of positive 1.22. Okay, so 1.22 is equal to some number X minus the mean, which is 0.1, divided by the standard deviation, which is 0.02. So I do that. And I get X equal to 0.1244. And now I found the 88.88th percentile of hedge fund returns. Okay, so 88.88% of hedge fund returns less than 12.44%, and I guess 11.12% of hedge funds return more than that. Okay, so that's an application, and that technology is very useful. So next class, so looking forward. All right. We have next class, which is not next week, which is in 2 weeks. That's good, right? In 2 weeks, we have a quiz. And also, next week, we're going to finish chapter 7. And the exam will go through chapter 7. So the midterm exam, which will be in 3 weeks, and will be located in the computer lab, will go through chapter 7. I'm going to post a practice midterm. And on Blackboard already, there's a practice solution set. If you have questions about the practice midterm, you can ask me in 2 weeks and say, listen, I did so in this question, please go over it. And I will either go over it during the entire class or afterwards during after class. You're welcome to ask me as well during class to go over certain practice solution questions.
Next week. Yeah. And then
Jason, like that. He says I think he's filming the class. So on the page. Probably gonna get lunch, then play some basketball or something. You out? Alright, see ya.
Yep.
Yeah, no, you never told me.
It's on right now. Oh, yeah.
I'll sing it again today. Me and I've been there. Oh, really? Actually, oh, really? Tell me the formula of residue errors.
What's it? Resident what?
Residue errors. It's something I can think of the value. I didn't know what that is. Gotta pay attention. Tell me the square root of English plus.
What's the one instance when the denominator is different than, well, for what type of probability question is the denominator different than the probability? So you can say, let's say, conditional probability, the denominator is different. Conditional probability is truncated.
Yeah.
So I might ask, but again, it's going to be more, it's not like, I want it to be so you can finish it like 3 or 4 documents.
Right.
But I also want it to be so you really, it's more like,
Concepts.
yeah, concepts, more than getting into the nitty. I want it to be a little bit, I want it to be fast, so you really understand, so you do this scheme. I might ask you, if you have a random variable, I might ask you, what is a probability? So a probability model would be, say, one column is the outcome, is the other probability, and that's the probability model.
Right.
Very sweet. So some just bigger picture questions
Yeah,
that are not in the homeworks, or
Right.
sort of like,
You have to know.
right, or I might ask you, what is the standard deviation measure? What is the variance measure? So the variance is measure average, so you know that's rate versus such a different concept in the last one.
Right, just to understand
Yeah,
and then
way back.
it's weighted out, and then the standard deviation is
The variance, the average is the square root. That's a very key concept. The variance is the average is the square root. Those are like, it's not like in the homework per se, but to me, it's like really a part of that what we're doing. Those are the types of things.
So can I shoot you an email if I can get
Yeah, those are the type of things. Those are the types of things.
Right, right. Okay, thank you.
concepts, not, I mean, I might ask a mathematical, I was thinking, I might ask, what is the interpretation of correlation? Which is a very hard question. So interpretation is, it's the slope. Plot the standardized x value, it's the standardized y value, it's the slope of the regression. That's a hard question. That would be a hard one. I might ask what the sample space is. I might ask you what the variance type. I might ask you the denominator. What is the denominator? What type of probability question do you truncate the denominator? So I might ask you, I could ask something like this. I could ask about give me an example of understanding what's disjoint and what's independent. So give me an example of something that's outcomes that are just disjoint, something that get into